Hello students, in this video I'm going to explain you about threads and multi-threading operating systems in operating system subject. This is very important topic, so let's get started. So basically what is thread? First of all, to begin with the topic, I want to explain you about thread because without knowing this you cannot understand that multi-threading operating system. So thread is basically the component of process. It is the small component of process, right? A process is further divided into subparts that is known as threads. It is a lightweight process because it's a part of the process. Okay, now it is used to improve your application's performance. Basically, it provides the property of the parallelism. Why? If you have one process, if you have divided that into the multiple subparts, that means if a user is executing the process, it can execute both simultaneously. That will give the parallelism property and that will increase the performance of the system, and it saves the resources and memory as well. Why? Instead of taking multiple processes, you have divided that process in threads. That's why there is a saving of resources and memory, because each process requires this memory like stack, heap, data and code. You have not requirement of the same thing again because you have divided that process in the form of threads. That is the benefit of using the threads in operating system. Now after you have done the threading in operating system, what happens? What are the common things and what are the unique things for the threads? You know, the shared things among the threads are code section, data section, heap, OS resources, open files and signal, right? These things were same for all threads, and the things which are unique for threads are thread ID, register set, stack and program counter. These will be unique when you divide the process in the form of threads. Now advantages of using the threads, you know, basically there are advantages are responsiveness. It provides very good response. Faster context switch means you can just switch from one process to another, one thread to another by saving your previous records as well. And now here's the resource sharing, means you can share your resource within the threads and within the processes as well. And here's the economic. It is very economic. With communication is also there, and utilization of multi-processing architecture is also there. Now what are the types of threads? You know, threads have two types, right? This is user level thread and kernel level threads. Now if you perform this thing over an operating system, that refers to multi-threading operating system, right? It is also known as multi-threading operating system. So advantages of threads are I discussed with you here, and now types: user level thread and kernel level thread. Okay, now user level thread, user, you can identify that a particular person is using. Now kernel, I have earlier told you in the previous videos that kernel is the core of the operating system, so you can refer it as OS. Now user is multi-threaded. Here what happens? User portion or user level is threaded, means that process will be threaded out, and in this OS is self-threaded out. Now this difference is oftenly asked in GATE exams and in semester exams as well. Okay, now let's get started with the differences. So user level thread and kernel level. User level thread, what happens? I earlier told you here that multi-threading in user process, and here what happens? Multi-threading in kernel process created without kernel intervention. Means that kernel is not aware that you are threading out of your user level threads. But here what happens? Kernel is itself multi-threaded, so it is known to this, right? Now context switching is very fast because the user is doing, and that is not based on the software that you are performing from yourself, your point of view. So the context switching is very, very fast. And here it is slow because the kernel is the core of the computer system. It is performing the task, and now it's getting threading up, so it will become slow. And if one thread is blocked, OS blocks entire process. You know, a process is divided into multiple threads. Now if one thread is blocked, OS blocks entire process because OS does not know that which threading system you have performed in your user level threading system. And here it is aware that how much threads are there and which thread have to be blocked. So individual thread can be blocked. Now here it is generic and can run on any OS. It is compatible with all operating systems, but it is based on specific OS. You cannot perform it on many operating systems, and it is faster to create and manage, and it is slower to create and manage. Okay, thank you.